This video is about how I can work out the matrix that represents a transformation that's given to me. So if I want to know the matrix that represents a reflection in the x-axis, what should these numbers be? If I want the reflection in the y-axis, what should these numbers be? Or a reflection in the line y equals x, or a rotation theta degrees around the origin, what should these numbers have to be that give me that transformation? So the way we're going to do that is we know that all linear transformations can be written as a 2 by 2 matrix A, B, C, D. Our job is to work out what A, B, C, and D are. The way we're going to do that is we're going to consider this matrix's effect on two very simple coordinates. We're going to look at the coordinate 1, 0, and then we're also going to have a look at the coordinate 0, 1. And we'll see what happens when we apply this matrix to each of those coordinates. So if I multiply this out, I'll have A times 1 plus B times 0, which is give A, and then C times 1 plus D times 0, so I'll just give C. So what this is telling me is, if I can find out what happens to the coordinate 1, 0, where it goes under the transformation, that new coordinate will tell me what A and C are. So I'll just repeat that. If I can find where the coordinate 1, 0 gets transformed to, whether it gets reflected by this, whether it gets rotated by it, whether it gets enlarged by it, if I can figure out where this goes to, then that will tell me what A and C are. Similarly, if I multiply this out, A times 0 plus B times 1, C times 0 plus D times 1. So if I can figure out where the coordinate 0, 1 gets transformed to, that will tell me what B and D are. B would be the x coordinate, D would be the y coordinate. So with that in mind, let's figure this out for a reflection in the x-axis. So I want to know what is the matrix that represents a reflection in the x-axis. So I've just drawn this out. I've got the coordinate 1, 0 here, and I know that if I can figure out where that coordinate gets mapped to, where does 1, 0 get mapped to under this transformation, that will tell me what A and C are. So reflection in the x-axis, well, this is the x-axis here. If I reflect 1, 0 in the x-axis, it doesn't actually move at all. This will stay exactly where it is because it is on the mirror line. So 1, 0 will get mapped to 1, 0. So I know these are the first two numbers in my matrix. Whereas if I were to reflect this coordinate in the x-axis, this would get reflected down here. This would get reflected down to here. So this is the coordinate 0, minus 1, which is my B and D. This coordinate gets mapped to 0, minus 1. There we go. So this is the matrix that represents a reflection in the x-axis. So for example, if I wanted to reflect this coordinate here, all I would do is I'd work out its coordinates and then multiply this matrix by the column vector representing that coordinate, and that will give me the new image coordinate. Next, if I wanted to know the matrix for a reflection in the y-axis. So again, let's consider the same 2 points. Remember, the image of 1, 0 will give me the A and the C. So let's think, where does that go? Well, a reflection in the y-axis, here's my y-axis here, this gets reflected over to be here at minus 1, 0. So this is the image of this point. So therefore, minus 1 is my A, C is my 0 from here. Now for B and D, let's think about what happens to the point 0, 1, that point there. Well, a reflection in the y-axis, this is the y-axis here, this point is on the line, so this is something called invariant. We will talk more about invariance in a later video. This is invariant, it doesn't move, so this is going to just stay as being 0, 1. It doesn't get mapped to be anywhere. Reflection in y equals x. So again, let's figure out A, C, B, D. Remember A and C is where the coordinate 1, 0 gets mapped to. So the coordinate 1, 0, if I reflect this in the line y equals x, which looks like that, this coordinate would get reflected to be over here, which is the coordinate 0, 1. So this is the image of this point. Therefore, my A is 0 because the x coordinate here is 0, and my C is 1 because the y coordinate of the image there is 1. So that was me reflecting this coordinate in that line. Now to work out BD, well, to work out BD I need to work out the image of the coordinate 0, 1, which just so happens I've already done it. It's exactly the same as this here. What happens to this point 0, 1? Well, that gets reflected to be here, 1, 0. So therefore, 1 is my B and 0 is my D, because 1 is the x coordinate of the image here, and 0 is the y coordinate. So this matrix here represents the reflection in the line y equals x. So that's how we can work out for reflections. Pretty simple, just draw a little diagram and figure out what happens to these two coordinates in each case. Rotations can get a little bit trickier. There is a formula, and I'm going to show you where that formula comes from. So we're going to apply the same idea. I'm going to see what happens to the point 1, 0 under a rotation of theta degrees around the origin, and then I'll be able to know what A, B, C, D is. So remember AC, these two numbers here come from the coordinate of the image point of this. So where does this get transformed to? So let's do that transformation. If this point gets rotated theta degrees around the origin, I should specify here, in fact, that whenever we talk about rotation, it is always anti-clockwise by default, because we need to specify a direction, and we do always anti-clockwise by convention. So I'm talking theta degrees anti-clockwise that way. So this point here would rotate around and end up to be, I don't know, somewhere like that, where that angle is theta. So it's just been rotated theta degrees around that. I'm interested in is what's this new coordinate, because this new coordinate here, this is going to give me my A, this is going to give me my C, just like before. So let's look at this point. Now I know that this line here, I know that that's 1 unit long, and I know that because it is basically this line here that got rotated around. This was 1 unit because of that 1 there. That's 1 unit, and it gets rotated around, so this is 1 unit. The size will not change as it gets rotated. And what I'm also going to do here is, let me just draw a little right angled triangle, because this side here is actually representing my x coordinate that I want to work out, and this side here is actually going to be working out my y coordinate that I want to work out. This is the y coordinate of that point, this is the x coordinate of that point. And I can do a little bit of trigonometry here. I could say that cos theta is the adjacent, which is x, divided by the hypotenuse, which is 1, And obviously x divided by 1 is just x. So I've worked out then the x coordinate here is just going to be the same as cos theta. Similarly, the y coordinate, I could say that sine theta is the opposite divided by the hypotenuse. So y divided by 1, which would just be y. So therefore I know that the y coordinate is given by sine theta. So straight away then I know that A here is cos theta and C is sine theta. Right, now to work out B and D. Well, remember they come from working out the image of the coordinate 0, 1. So what would happen to this point under a rotation of theta degrees around the origin, anti-clockwise? Well, just in the same way as this moved to here, this is going to move to be like that. So that will look like that, where again that will be theta degrees. And we can use exactly the same logic as what I did here. I want to work out what the coordinate of this point here is, because that's going to be my B value and this is going to be my D value. So just like before, I know that this length here is 1 because of this. Therefore, this length there will have to be 1 as well, just to be consistent. I'll do that in green, don't know why. And just like before, I can draw a little right-angled triangle here. Now, the key thing here is the x coordinate here, that is being given by this. And also notice that it's going to be negative. The x coordinate down here is going to be negative. So we'll bear that in mind. I know that that's going to have a negative. We're in the negative part of the x here. And this is going to give me my y coordinates here, which is fine. That's still positive. Now doing a bit of SOHCAHTOA here, so I can say that cos theta is the opposite ignore me, it's the adjacent, which is y. The adjacent in this triangle here is y. Yes, x is the opposite there. Y is the adjacent. So cos theta equals y over the hypotenuse, which is 1. So cos theta equals y. So it's actually the y coordinate here that is cos theta. I can say that sine theta is the opposite, which in this case is x, divided by the hypotenuse, which is 1. So sine theta is equal to x. But remember, we needed this to be negative. So this is actually going to be minus sine theta, not just sine theta. So we know that this is minus sine theta, and this is cos theta. And we now have the formula for the matrix representing a rotation theta degrees anticlockwise about the origin. This formula is given to you in the formula booklet. Right, let's have a look at a couple of examples using that then. So, example 1, we are told to find the matrix representing a 90-degree clockwise rotation around the origin. So first of all, I've noticed that this question said clockwise, and I need this to be anti-clockwise, as we saw before. So therefore, I need to think a 90 degrees clockwise rotation is like that. So therefore, anti-clockwise, that's the same as a 270-degree rotation. Let me just repeat that. If I have a 90-degree rotation clockwise, that's the same as a 270-degree rotation anti-clockwise. So, therefore, theta is 270. So I can use that in the formula that we just saw. So just putting 270 here, 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 and here. And now I know that cos 270 is 0, sine 270 is -1, minus sine 270 is 1, cos 270 is 0. So this is the matrix that represents a 90-degree clockwise about the origin, which should hopefully make sense, because if I rotate 90 degrees around the origin in a clockwise direction, then the point that was here at 1, 0 now rotates to be down here at 0, -1. And the point that was here at 0, 1, that would rotate 90 degrees clockwise to be here at 1, 0. So this should also make sense in the context of what I was saying at the beginning of this video, where this represents the image coordinate of the point 1, 0, and this represents the image coordinate of the point 0, 1. Right, second example and last bit of the video. We need to describe the transformation given by that matrix. Now straight away, I don't think that looks like a reflection. That to me looks like a rotation. So I am going to compare that to the rotation formula. So just comparing that, then I can see that cos theta has to equal 1 over root 2. Just comparing both of those. So I can say that cos theta equals 1 over root 2. So if I do inverse cos, I get 45 as a possible answer. And from what we've seen before in solving trigonometric equations, I know that 315 is also another solution. Because looking at the cos graph, if 45 is my principal solution here, then using the symmetry of the graph here, I know that there'll be another solution here where I take away 45 degrees from 360, and 360 take away 45 is 315. So these are the two different angles, 45 and 315. These two angles here will both give a cos value of 1 over root 2 here. So I know theta has to be either 45 or 315. I'm then going to check the sine theta, because I know sine theta has to either equal 1 over root 2 or minus sine theta has to equal minus 1 over root 2. So in either case there, they will both simplify to give this. And then if I do inverse sine of both sides, the calculator will tell me the principal value of 45. But I know from the symmetry of the sine graph, if that's 45 here, I know there'll be another solution here, taking away 45 from 180, which gives 135. So according to this bit of the matrix, theta would have to equal 45 or 135. So comparing both of these, because they both have to be true, the only answer that is consistent is 45 degrees, so therefore I know theta is 45 degrees, and now I can say therefore that this matrix here represents a rotation 45 degrees anti-clockwise around the origin. So that is how we get that formula for a rotation around the origin, and just remembering how we can get this bit here, just generally how we can work out A, B, C, D. This is always about drawing these, drawing a diagram and seeing what happens to the coordinate 1, 0, and then what happens to the coordinate 0, 1. Those are the key things.